Hello everyone, welcome to my channel, The Big Boolean Theory. This video is part of a lecture series on operating systems, and currently we are on the first module of this course, that is the introduction module. And the idea behind this module is to give you a basic introduction to operating systems. So till now we have completed the first two topics in this module, that is the computer hardware review and introduction to operating systems. So now what we are going to do, we are start with a new topic, that is the compute stack. So what is the compute stack? We have already seen the compute stack in the previous topics. So basically this is a view of the computer system where we say that the computer system is composed of a stack of multiple layers. So what does the stack look like? At the very bottom, you have the computer hardware. On top of the hardware runs the operating system, and over the operating system runs the user applications. So you see there are several layers that make up the computer system. However, this compute stack that we know of is a basic version and kind of incomplete. So in this video, we are going to look at how the complete compute stack looks like. So basically there are some missing layers which we are going to see and see how the complete compute stack looks like. So once you have a good understanding of the complete compute stack, you can say you understand how the computer system works. So till now what we have done is that we have just looked at the computer hardware separately or the operating system separately in the previous few topics. So now we are going to look at all the components that come together and make the computer system. So without further ado, let's get started and study the compute stack. So let us start the discussion with this basic compute stack. So this is something which we have already seen in the previous videos. So as you can see, there are three layers in the basic version of the compute stack. At the very bottom, we have the computer hardware, and then there is this hardware interface. And on top of this hardware interface, there are several layers of software. So as you can see, there are two layers of software currently. One is the operating system, and then we have the user applications. And finally, we have the user. So as I said at the starting of this video, this basic version is incomplete and there are some missing layers in this compute stack. So let us go ahead and see what are those missing layers. So this is how the complete compute stack looks like. So as you can see, what we have done, we have added two new layers. One is the programming libraries and the other is the user interface applications. So basically all the layers that were part of the previous basic version of the compute stack, they are also part of the new version. So hardware, operating system, and the user applications are still there. We have just added two new layers. One is the programming libraries and the other is the user interface applications. So now what we will do, we will basically go through each layer one by one and discuss what is their functionality and what is the interface that they expose to the layers above. So we'll start with the computer hardware, right? So at the very bottom, we have the computer hardware, and computer hardware basically consists of the CPU, memory, IO devices, basically all the physical objects that you see when you see the computer, the chips, the devices, right? So this is what makes up the computer hardware. And this is the interface that the computer hardware exposes to the layers of software that run on it. And the point is, this hardware interface is very complex to write programs over. That is why we have the next layer, that is the operating system. So the user applications, the programs that we launch on the computer system, basically they cannot run directly on the hardware interface because it is too complex, as I said. So what the operating system does, it is a special piece of software whose fundamental responsibility is to manage the computer hardware and make it easy and efficient to use. So what the operating system does is it provides an interface that is called the system call interface. The system call interface is another name for the interface provided by the operating system. So this interface is much more simpler than the hardware interface, right? So one of the responsibilities of the operating system is to simplify the hardware, right? And as you can see, the operating system runs on the bare metal. So when we say bare metal, we mean that it runs directly on top of the hardware interface. No other piece of software is allowed to run directly on the hardware interface except for the operating system. So it provides the base on which all other software are based upon. So this was about the operating system. Now let us talk about the programming libraries. So now let us discuss what are programming libraries. So as you can see, a programming library is a layer of software that sits between the user applications and the operating system. So the point is, although this system call interface that is exposed by the operating system, it is simpler than the hardware interface, but it is still too complex to write programs for. So what the programming libraries do, they simplify this interface even further and provide another interface, that is the programming interface. And now we as application developers write our programs over this interface. This is much simpler interface to write programs for. And what do these libraries contain? Basically, the libraries contain a set of pre-written code for common functionalities that would often be required by the programmer. A few examples of such operations are, for example, standard input output operations, then file manipulations, string manipulations, mathematical functions. So as you can see, these are some of the operations that are often required by the programmer frequently. So instead of having the programmer write these code, what the programming languages do, they provide all these functionalities as a set of pre-written code in the form of a library. And now the programmer can go ahead and borrow the code in this library and reuse it in their own application code. So the idea is not to reinvent the wheel again and again. So someone has written out these commonly used functionalities for you in the form of a library, and we as application developers can just reuse this code in our application. So this is what the programming libraries do. And now let us see some of the examples to understand how programming libraries are used. So let us look at some examples of how we can use these programming libraries. So here I have taken 3 examples from common programming languages like C, Java and Python. So here you can see there are 3 code snippets, and at the top of each code there is a section where we have imported the programming library. And the way to import programming libraries varies as per the language that we use. So for example, in C we include header files, in Java we import packages, and in Python we import modules. So although all these 3 mechanisms look different, they are doing the same thing, that is importing the programming library that has been provided by the language. So now let us look at the functionalities that these libraries provide. So common examples are string.h header file. So the string.h header file contains string manipulation operations, and as you can see, the programmer has directly used string copy, string concatenation in their code. So now they don't have to define these functions in their code themselves. They can just reuse the code that is part of the standard library. Another header file is the math.h. Here mathematical functions are defined. So one of the example is the square root function. And finally, let's talk about the time.h. Here functions related to handling time and date are defined. So you can see in this program, time, local time functions have been used, right? So commonly used requirements of the programmer has been captured in the programming libraries, and now the programmer does not have to implement them themselves. They can just reuse the code that is part of the programming library. So just like C, we have in Java and in Python. So we have several useful libraries as part of each programming language. And one common thing you can see, the mathematical functions. Let's talk about these functions. So for mathematical functions in the C language, we have math.h header file, and similar to this in Python we have the math module. So these two are kind of equivalent. They provide mathematical functions in the respective languages. So the point is, these common functionalities are part of each language library. So similarly, time.h has the equivalent of date time module, right? So this is how the programming libraries are defined and used. So they make the job of the programmer quite easy by providing an interface that is very simple, and it has all the not all but almost all major functionalities that would be required by the programmer. So this is how the programming libraries work. So now that we have talked about the programming libraries, let us talk about the next layer, that is the user applications. So this is the layer with which the user is actually concerned with. So what are user applications? The user application is basically a program, and a program is a sequence of instructions that is executed by the CPU. By executing this sequence of instructions, some input data is manipulated and processed to get some output. So this is how user applications work. So the fundamental idea is that every user application is trying to solve some computing problem for the user, right? And some of the examples are, for example, web browsers, word processors, media players, gaming applications. So there are so many applications that are there in the computer system. And the interesting thing about user applications is that although all these user applications are trying to solve different computing problems, they are using the same set of compute resources, the same set of hardware resources, CPU, memory, set of IO devices. Using this same set of hardware resources, these user applications are able to do a wide variety of things for the user. So this is how the user applications work. So now let us look at the next layer, that is user interface applications. So now let us discuss about the topmost layer in the compute stack, that is the user interface applications. So basically the interface applications and the normal applications that we just discussed are the same thing, right? They are both programs that have been written over the same interface, that is the programming interface. But the only difference is that the special thing about the interface applications is that they allow the user to launch these user applications, right? By itself, these interface applications are not trying to solve any particular computing problem for the user. Their sole purpose is to help the user launch and interact with these user applications. So that is why it has been shown at the same layer, but with a thin encapsulation over the user applications. They basically act as an intermediary between the user and the user applications. So they not only help the user to launch these applications, they help the user to interact with the overall computer system in general. And that is why this interface of the interface applications is called the user interface, with which the user interacts with the overall computer system. So now we will look at some of the interface applications and understand how they work. So here we have two examples of user interface applications. The first is the graphical user interface, also called GUI, and the second is the command line interface, also called the CLI. So basically in the graphical user interface, so whenever you boot your system, you are presented with a screen. This is a desktop screen and there are several visual components that are present on the screen with which you can interact. So some of the visual objects are, for example, the icons. So for every user application, there is a representative icon like a logo, and you can double click on that icon to launch that user applications. So apart from the icon, when you launch this user application, you will be presented with a window, right? So this rectangular area with which we interact with the application is the window. This window has several menus, and when you click on a menu, there is a drop down from which you can select several options to perform some tasks. There are some buttons to interact with this window as well, like minimize button, maximize, close button. And finally, you have some scroll bars. So this is a vertical scroll bar. This is a horizontal scroll bar for navigation. So you see, there are several visual components, the icons, windows, menus, buttons, scroll bars, and all of these constitute the graphical user interface and make the interaction very easy for the user. So this is a very user-friendly way to interact with the system, and it is commonly used. So the next option in terms of user interface application is the CLI, or the command line interface. So in this interface, basically we have a command terminal or a command interpreter, and within that there is a command prompt where the user can type in the commands that they want to execute. So here, as you can see, the user has typed in a command with some options, and the command terminal will parse those commands and execute it for the user. So basically the interaction is like, for anything that you want to do, you have to type in a command. So it's a very text-based interface. There are no visual objects in this command line interface. So you might wonder that why would anyone go for this kind of difficult interface as compared to the GUI? Basically, the upside of the command line interface is that all the features of the system are exposed by the command line interface. Basically, sometimes some of the advanced features are not available via the GUI. So in that case, you have to use the command line interface. It provides more control over the system, and it is very popular in Unix-based operating systems. So these are the two ways in which we can interact with the system. One is the graphical or visual way, the GUI, and the other is the text-based, a command-based interface, that is the command line interface. So now that we have talked about the different layers in the compute stack, let us now shift our attention to the user. So there are different types of users in the computer system, and this diagram gives you a basic idea. So the very basic user is the one that is not concerned with writing any kind of software. So they are only concerned with using the existing applications or the softwares that is already available in the market. So these are just the consumers. They are basic users. They are not concerned or involved in any kind of software development, right? So this is the first class of user. They are only limited to this topmost user interface of the computer system. Then apart from the basic user, we have a set of more advanced users that are not only concerned with using the software but also writing them. So these are called software developers. And as you can see, there are several layers in this compute stack and several interfaces. And depending on the interface on which they are doing software development, there are different kinds of software developers. So let us talk about the first one, that is the application developer. So basically the application developer is responsible for writing these user applications, and they write their programs over the programming interface that is exposed by the libraries. So all of us start our software development journey as an application developer, and the majority of development that goes out there is at this level, the application developer who are writing user applications to solve some computing problem for the user. Now let us talk about the library developer. So basically there are a group of developers who are involved in the development of the programming libraries. And as you can see, they are doing development directly over the system call interface, which is much more complex than the programming interface. And the libraries that they write provides a base for the user applications. So basically the libraries that is being developed by the library developer will be directly used by the application developer in their user applications code. So this is what the library developers do. So now let's talk about the OS developers. Finally, there are some developers who are involved in the development of the operating system itself, right? So as you can see, operating system is the base of all other software, right? And these developers are directly programming over the hardware interface. So they will be writing the operating system, the device drivers, and programming directly on the bare metal. So as you can see, there are different interfaces in the compute stack. And as you go down the compute stack, the level of complexity increases. And you can guess that as the level of complexity of the interface increases, the expertise that you require as a developer to program on the interface is also high. So from going from top to down, the level of the interface is getting complex, so the expertise that is required as a developer also increases. So you can see these are the different kinds of users that exist in the computer system. So guys, this was it for this video. In this video we talked about the complete compute stack. We briefly discussed each of these layers, and we also touched upon the different types of users that exist in the computer system. So this was it for this video. Thank you very much for watching, and I'll see you in the next video. Thank you.